What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at how to multiply and divide indices, and this is something that will pop up again and again all throughout your mathematical career. Being on top of what an index actually means is the major skill, and if you're not 100% on top of that, please watch my last video because we're going to use some terminology that's specific to this topic. So the biggest idea that we need for this lesson is that indices just represent repeated multiplication. So 2 to the power of 3 is saying the base 2 is multiplied by itself 3 times. So 2 times 2 times 2. This repeated multiplication is really annoying to write out in big sequences. So we use an indice to highlight the exact same information in a way simpler way. So because we know that it is repeated multiplication, if I give you a question like this, 2 to the power of 3 times 2 to the power of 4, the answer can be found by just expanding it out. 2 to the power of 3 in black here is 2 times 2 times 2. And then I have a multiplication sign, so I'm going to put that in. And then 2 to the power of 4 in blue is just 2 times 2 times 2 times 2. So really, I've just got a longer string of repeated multiplication. I've still got the base 2, but instead of having 3 and 4 of them, I've got 7 in total. So my final answer is just 2 to the power of 7. So knowing the fundamental idea that an indice is just repeated multiplication will take us to the rule. Because we don't want to have to write out a big string of numbers every single time, that would defeat the purpose, we're going to have a shortcut. And it's really simple. All we have to do to multiply two indices of the same base is just add the powers or add the small numbers and keep the base the same. So if I had something like this, 7 to the power of 4 multiplied by 7 to the power of 10, all I've got to look at is the two small numbers, 4 and 10, and I have to add them. The base must remain the same because it's repeated multiplication. So it's 7 to the power of 14. Full marks, you're done. We can also apply this to algebra. If I've got x to the power of 3 multiplied by x to the power of 4, even if I'm not 100% on top of algebra, we can still follow the same pattern. Oh, the base has to stay the same, so it's still x, and I have to plus the small numbers, so it's x to the power of 7. Finally, I could have something that looks like this, 8 to the power of 2 times 8. Sometimes my students completely freak out about this, but the ideas are exactly the same. The big thing behind this is that 8 by itself is really 8 to the power of 1. We just don't write that because that's 8 multiplied by nothing, so it's just an 8. That means we've got a pretty easy answer. 8's still the base, and we had 2 plus 1, so it's 8 to the power of 3. If you don't love imagining that 1 on top of the 8, again, let's just write it out in expanded form. 8 to the power of 2 is 8 times 8, and then there's times 8 left over, so the shortcut to this must be 8 to the power of 3. Division is just the opposite. Instead of adding the powers, we're going to minus them. We're going to see why with an example, but I'm sure you're going to find this really easy. So if I've got 4 to the power of 6 divided by 4 to the power of 4, I'm going to write this out in expanded form. So I'm going to throw this onto a fraction. I've got 4 times by itself 6 times at the top and 4 times by itself 4 times on the bottom. Remember that if we've got the same factor on the top and the bottom of a fraction, we can cancel them out. That means I can get rid of 1 times 4 from the top and the bottom, and another, and another, and another. Now I'm left with just 4 times 4 at the top of the fraction. Well, 4 times 4 is 4 to the power of 2, so all that's left is 4 to the power of 2. Again, we don't want to write this out every single time, it'll take way too long. The big shortcut is to just subtract the little numbers, but keeping the base the same. 4 to the power of 2, easy done. So if I've got 9 to the 7 divided by 9 to the 5, all I've got to do is minus those two numbers. So the answer is 9 to the power of 2. Same thing with our algebra, b to the power of 3 divided by b to the power of 2. 3 minus 2 is just 1. So this is equal to b to the power of 1. But we don't want to write to the power of 1. We can just leave it as b. Happy days. So the only way that we can get this incorrect, right? We're just adding and subtracting. It's pretty easy. But we need to make sure that we cannot do this with different bases. Because we're only talking about repeated multiplication, if we have different bases, there's no way that we can add these two numbers together. If we have a look at this example, 2 to the power of 2 times 3 to the power of 2, if I write this out in extended form, I've got 2 times 2 times 3 times 2. This is not repeated multiplication. I've got 2 times 2's and 2 times 3's. They're different. I can't go, 6 to the power of 4. It doesn't work. Another mistake some of my students make is they go, I need to add numbers together, so it must be 5 to the power of 4. Again, 5 to the power of 4 is saying 5 times 5 times 5 times 5, and there is no 5's in this sequence, so that cannot be right. So we just need to know that there's no way we can multiply these easily in the way that we've been learning if the bases are different. We can just leave the answer as 2 to the power of 2 times 3 to the power of 2. Thanks so much for watching this lesson, and I'll see you later.